This video is going to go over problem number 13 from your molar mass and molar conversion worksheet. So this one is also a little tricky, kind of like number 7A, B, C, and D. So I'm going to go through this one. It's very, very similar. So it's asking for a total number of oxygen atoms. And so we're definitely going to be moving down to particles on our mole map. And we're starting at 79.5 grams of our sample. So currently we're in mass. So what we're going to want to do is go from mass to moles, and then moles down to particles, and then this one's going to require that one extra step too to get into atoms. So let's go ahead and get started. So the first thing I know that I'm looking at is diboron trioxide. So diboron trioxide is made up of 2 boron and 3 oxygen. So I'm going to figure out what its molar mass is. So the molar mass of this is 2 times the molar mass of boron plus 3 of the molar mass of oxygen. I'm going to add that all together and I get 69.62 grams per mole. That means that 1 mole of B2O3 is equivalent to 69.62 grams of B2O3. So I'm going to be using this as my conversion factor. I'm going to start with my given, which is 79.5 grams of B2O3. And I can see that I'm in grams, so I'm going to want to get out of grams. If I'm looking at my conversion factor, that means that this is going to be on the bottom. So 69.62 grams of B2O3 for every 1 mole of B2O3. So then that's going to get rid of grams, because it'll be grams over grams and they'll cancel, and that leaves me in the unit of moles. I don't want to be in moles, I want to be in particles, so I'm going to do another step, and I know that every 1 mole of B2O3 is actually 6.02 times 10 to the 23 molecules of B2O3. So I'm going to use this as my second conversion factor. So I'm currently in the unit of moles. So that means I'm going to put moles on the bottom. So every 1 mole of B2O3 is actually 6.02 times 10 to the 23 molecules of B2O3. Moles will cancel when I multiply across, because it'll be moles over moles. Right now I'm in molecules of B2O3, which would be great, except for I'm asking you the total number of oxygen atoms. So we're going to do that similar step as we did in number 7, which is again not really on the mole map. But if we look at the molecule, we can see that 1 molecule of B2O3 actually contains 3 atoms of oxygen, right? So when I did the molar mass up here, I said that for every 1 of those molecules, I have 3 oxygen in it. So then I'll use this as my final conversion factor. I want to get out of molecules, so molecules will go on the bottom. Every 1 molecule of B2O3 contains 3 atoms of oxygen. And then I'll multiply all the way across. Molecules will cancel. So it'll be 79.5 divided by, well, technically times 1, divided by 69.62 times 6.02 times 10 to the 3, again, technically divided by 1, times 3 divided by 1 again, and then your answer should come out to be, I've got 2.06 times 10 to the 24th atoms